Good morning, everybody. Welcome back to lecture number
24.
Today we will continue talking about the inverting amplifier, and here is a quick example that I would like to talk about, which is the voltage summer. So we already draw the circuit. The only difference from the classical configuration is we have another VB connected to the same negative input. So step number one, verify that there is a negative feedback. That's correct. Step number two, what was it?
The virtual ground.
So we have here a virtual ground, or the voltage drop between the negative and the positive, or the positive and negative, is zero. Call this Vx, okay? So what is IA? IA is V input minus 0, or VA minus 0 over RA. IB equals VB minus 0, okay? This is VB, this is a virtual 0. So VB minus virtual 0 over RB. Is this a circuit? RB. Now, IA and IB, would they go inside the triangle? No. So I0 in both inputs of the triangle. So they will go to IF. Why we call it F, RF, IF in this example? From the word feedback, okay? F from the word feedback. So what is IF? Is IA plus IB. Get it?
No.
Okay. Do we know IX?
No.
No, we don't know. We have to do KCL to know it. So there is no point of saying V output equal I output plus RL. Instead, we calculate IF directly from the equation. So what is IF? IF is 0 minus V output over RF. Right? IF is 0 minus RF, no, minus the output over RF. So, which implies IF is what? IA plus IB equal minus V output over RF. What is IA? It's VA over RA. What is IB?
VB over RP
Equals
minus V naught.
Minus V output over RF. So what he is trying to calculate here is not find the gain, because the gain is what? One input over one output. Here he is asking about write V output as a function of VA and VB, because you cannot say a gain if you have two inputs. Okay? So it's very simple. V output is minus RF times VA over RA plus VB over RB. And as you can see, we are summing the two signals. So VA is 2 volts. Let's say all the resistors are 1. VA is 1, VB is 1. This is a calculator. It does for you too. Right? So this is what we call a voltage summer. Okay? Now, if we make this, for example, 10 or 8, and every time I put a signal 1 or 0, 1 or 0, can you guys envision a digital signal being generated from this? For example, this is 1 and 0. 1 plus 0 is what? You have 1 and 0. You can write digital signals, 1 and 0, 1 and 0s, right? You can sum them together and then you have an output. Or this can be like an AND operation. 1 AND of 0 is 0. We'll talk about this later. But the idea here is you can mix signals using operational amplifier. Before, we did not have this ability. Before, you cannot merge V input and V output together. The only thing we had before is KVL, where if you have a voltage of 5, this is minus 3, they will cancel each other, and then you have what? 2. Okay? What is the input impedance. What's the equation? It's V input over I input. So how many input impedances we have? We have how many inputs we have so far?
2.
We have input A, input B. So because here it's virtual ground, the I, so let's say for our input A, we have I input of A, which is what we call it A. So V in A over I of A, which is equal to R of A. So R of A, we already calculated it to be VA over IA. You can call this V of A over IA, okay? Similarly for part B, the input impedance is VB over IB, which is equal to RB. Now, for the output impedance, because the V output does not rely / depend on RL, our output, all shepherd P is output. Impedance is what? 0, meaning it can drive any load of interest. Okay? So the output voltage is independent of the load resistance, therefore the output resistance is 0. Okay? This is the classical connection numerical example. It's very easy to solve. I think we did solve it before. This is a numerical example for the example we did last class. Okay? Now the last example of the inverting amplifier is what do we have here? We have, up until this point, is a system, right? What is that? Classical negative inverting amplifier. I'm not going to draw it on board. Instead, what we're going to do is we're going to have a system approach of solving such problem, okay? So, what I'm going to do, I'm going to draw block diagrams, okay? What is this block up until this point?
ناخذ الفي اوت
What do we call it?
system negative amplifier.
Negative, I think we call it inverting amplifier or classical inverting op amp, okay? You agree with me?
Yes.
Then we have, think of this as VA. I'm trying to make your life easier. Think of this. You remember this example, VA? Think of this as from here all the way to the left is just VA. Isn't this VA and this is VB and this is the summer?
Yes.
So we have two systems together. That is the smartest way of solving this example. Let me repeat. The first stage, we call this وش نسميها? Stage. The first stage is inverting amplifier. The second stage is summer. So here we have what? Summer. اللي هو regional. So we have a two-stage system. So check the negative feedback. For every op amp, there is a negative feedback. There is negative feedback. Negative feedback means a cable from the output goes to the negative input. Now we name the current and the source and they solve by one by one. Now, I'm not going to solve it on board. I'm going to walk over the solution for the interest of time because it's also a big circuit. So direct application of the laws, it gives us, now I don't need to do that. I can call this V3. So V3 is minus R2 over R1, V1, get it? Mm-hmm. So R2 is what? 20K over 10K. That's what? It's going to be minus. So V3 is going to be what? Minus 2 times V1. Okay? Anybody doesn't see it? V3 is what? Minus 2 V1. Because this minus 2 is minus R2 over R1. Then we have, think of this as VA. We have V2. So VA is what? V3, صح? VB is what? V2. Can I sum them together? What's the summary equation? V output equals minus RF. VA is 3, is going to be V3 over RA. What is RA? R3. Plus V2 over R4. Now what is RF? Is R? 5. Get it? That's the fastest way to solve this example. So what is RF? 20 over 10, so it's going to be minus 2 times V3 plus V2. Get it? But V2 is minus V1. So this is minus 2. V3 is what? Minus 2 V1 plus V2, which is going to be what? 4 V1 minus 2 V2, and that is the relationship between the output and V1 and V2. All get it? Get it? Okay. This example also talks, yeah, that's the requirement. Just find V output over V input. Any question about this problem? Remember this, okay? When you see two op amps together, it means you have two stages. In this case, we have inverting op amp. The other case, we have summer. Okay? And I'm going to ask you, Nahli, where is this point in the circuit?
Before R3.
Before R3, which is here. You're right. Okay? And where is the point output here? Is this out? So the whole system, this one, we call it summer. The whole system, we call it inverting amplifier. Now, non-inverting amplifier. What did I tell you about? What does the word inverting mean? The output usually has a negative sign when you put the input, or the gain is negative. Non-inverting, it means the output, non-inverting means the output is fed because the input signal is fed in the positive terminal. So if we feed the input to the negative terminal, we're going to have a negative gain. If we feed the input to the positive terminal, what we're going to have? Positive gain. So it's the same thing. The output is positive, is expected to be positive. And then we also call it has also the negative feedback, which is different than inverting and non-inverting. Negative feedback means part of the output is fed where? To the negative signal. So non-inverting amplifiers, they have two features. The first feature is the output, the gain is positive because the input is fed to the positive terminal. And then they also have negative feedback because a cable from the output is pulled all the way to the negative input terminal. Okay? Now, in this positive or non-inverting amplifier, we're going to apply the same concept. Vx is V plus minus V negative is 0. So this implies V1 that appears here would appear here too. That's why students do not like non-inverting amplifier. I personally do not like it, but we need to understand it. Nasrallah, what is the voltage drop across R1?
0. No.
No, it's not 0 this time.
To 0.
No, it is. So it is connected here, okay? Now, this dashed line, it is connected, okay? It is connected. So the voltage here is same as the voltage here. What is the voltage here?
Oh,
You zoom in, man, it's too small. Again, I'm asking you what's the voltage here? This is connected to the negative terminal, صح? The negative terminal and the positive terminal have the same voltage. So what is the voltage across the positive terminal?
PM.
V input. So V input would appear here. Get it? Get it? Now, that's the first information is V input would appear. So this is Vn. This is, we call it Vx. Call it Vx. Okay, not Vi. Call it what? Vx. This one is V1. So what is V1? Should I calculate it from V input? No, because I can find it through V output. Now, this is, what's the voltage drop if you add R2? What's the voltage drop here? V output. So what's the voltage drop at this triangle? V output. Do you see a VDR here? Because we don't have current enters here, so R2 and R1 is in series. So can I say the voltage drop across R1 is R1 over R1 plus R2 times V output?
Yes.
Do you see it? Again, let me repeat. What's the voltage drop here?
Yeah.
V output. What is the voltage drop across the R2 and R1 together?
Also PM.
V output. Why? Because R2 and R1 in series. Why they are in series? Because there is no current بيخرب عليهم هنا. Yeah, there is a connection here. بس ما تسحب current. The current here is 0. Because the current here is 0, we can say V1, which is the voltage drop across R1, is R1 over R1 plus R2 V output. But I know that Nasrallah just told us V1 and V input are equal. So this implies I can replace V1 with V input. And I can find the relationship, which is V output over V input is going to be 1 plus R2 over R1. Basically, it is V input equal R1 plus R2 times V output. So V output over V input equals what? R1 plus R2 over R1. R1 over R1 is what? 1 plus R2 over R1. And that is the gain equation. It is positive because the output doesn't have a negative sign. They are all in phase. V output and V input, they have the same sign. And it's a non-inverting amplifier because we're providing the input to the positive terminal. Okay? Key mistake many students do is they put a ground here at the beginning. That's wrong. What Vx, this is called Vx, correct your notes. This is what? YouTube. This is what? Vx. I don't like Vi. Another mistake students make is they do not recognize that R2 is in series with R1. It's similar when we had R3 before, remember? We told you R1 and R3, they are in series for inverting amplifier. So that circuit has a positive output. Now what is the input impedance? The input impedance, what did I tell you the formula of the input impedance? It's V input over I input, right? Get it? What is I input? I input, ya shabab, is II, which is 0. There is no current that flows from the voltage source all the way to the positive terminal. So the input impedance, is what? V input over I input. So what is V input? Is actually V input. What is I input? In this diagram, it's II, so it's Vn over II. What is II?
Zero.
It's 0. So V input over 0 is what? Infinity. Get it? فرجين مشوا. Maybe they have. You have a major today or something? Midterm? Any big exam today? Okay. So the input impedance is infinite because the input current is 0. Since the voltage gain is independent of the load, we repeat the same story. The output over V input, the gain, doesn't have any RL. Because it does not have an RL, it can drive whatever load is connected. So the output impedance is 0. إذا تورطتوا يا شباب في الامتحان في الأوب أمب الأوتبوت impedance خلها 0 إذا تورط. Okay? واضح؟ والinput impedance you have to do analysis. It could be R1 or infinity or combination of 2 or 3 resistors. But this formula for R input is the most important formula. It's V input over I input. What is I input in this case for a non-inverting amplifier? مش على الغامدي؟ 0. V input over 0 is what? So it has infinity input impedance. Get it? Therefore, under ideal assumptions, the non-inverting amplifier is also an ideal voltage amplifier. What it does, if I put here 2 volts, it's always larger than 2 volts. Because 1 plus number. This number is always going to amplify your voltage. So now we know, ya Shaheen, that a non-inverting amplifier, it amplifies the voltage. If I put 1 volt, it will be more than 1 volt in the output. There is a stupid circuit because we have something called a voltage follower. So a voltage follower is actually like a buffer. إيش معنى buffer? Can you open Wikipedia? Buffer, the word buffer.
Increase the current of the circuit.
Yeah, but وش بالعربي؟ أنا ما أعرف وش بالعربي.
Same voltage, increase the current.
Yeah, بس إيش هو اسمه بالعربي؟ buffer.
يبطئ يبطئ.
إيش اسمه؟
لا أنا بقول لك يعني.
I don't know. I'm asking you guys. Taking a break. What is a buffer?
عازل.
عازل.
مخفف صدمة.
So you're right. So عازل يعني it can provide more current but maintain the same voltage. مخفف صدمات. But write it in the form of electrical engineering, electric circuits. So a buffer in electric circuits is used to copy digital input and isolate it from any output load. So you're right, it increases the current. ما لها اسم بالعربي. Okay.
شو المخزن المؤقت.
Yeah, مخزن مؤقت. That's interesting. Yeah. But what I'm saying is, this circuit is a non-inverting amplifier. The only difference here is R2 is short circuit. So R2 is 0. So V output over V input is just 1. But it has an output impedance of 0. So it can drive as many loads as possible. So it can allow whatever system to push more current to the load. Get it? هو زي ما تقول طبقة عازلة في stages. We usually put the buffer to isolate whatever load from connect. يعني for example إذا بتوصل speaker مرة قوي على السيارة تمام؟ You don't want to damage السيارة. They usually put buffer. في أحد عنده اهتمام في المسجلات حقت السيارات ستيريوز؟ البفر ذكروه كذا أسهل. عندك سيارة تبي تحط عليها سماعات تمام؟ وما تبغى السماعات العالية هذه تسحب تيار كثير من السيستم حق الأوديو. فتحط بفر عشان يسحب من السبلاي whatever necessary current. واضح الشرح؟ واضح؟ Do you want me to repeat it again?
Yes.
Okay. الار نود وش هي؟ سماعات السيارة، سماعات الكبيرة. الفي انبوت ايش؟ الستيريو حق السيارة اللي بتشبك عليه الجوال. الاوب امب هي بطارية السيارة والسيستم، هي السيستم حقك الاوب امب في السيستم، سبلايد باي سيستم. انت لما تشبك سماعات قوية بالستيريو تخاف تخربها احيانا. تعطبها، بدل ما تعطبها تشبكها على اوب امب
عشان يسحب من السيارة، من بطارية السيارة تيار مباشرة لإيش؟ للسماعات الضخمة، فما يخرب عليك السيستم حق المسجل. Get it؟ واضح وش البفر؟ So we call this a voltage follower. الجين 1 ما ابغى جين منه، كل اللي ابغاه منه يعطيني current من الأوب امب to supply this load. Okay? 70% of electrical engineers don't know this circuit. Okay? We have 5 minutes to do the last example. So find the voltage gain and the input impedance of the circuit below with the switch is open and with the switch is closed. So let's do it when the switch is closed first, okay? So what is the circuit? We have op amp. Again, we love to see this Nasrallah, right? Here we have ground connected, صح؟ نرتاح نفسيا. نرتاح نفسيا ليش؟ لأن نقدر نحط ground هنا. الجراوند يسهل علينا أشياء واجد. Get it? Keep in mind we're connecting a resistor R, and then in the same positive terminal we have another R, and then we have V input. And here we have IN, I1, I2, and then this R1 is connected to the negative, and then we have another R load, V output. We call this IX, صح? And we call this always VX, right? And then this is R, or we call it RF, it doesn't matter. Here they call it I3, plus, minus, plus, minus, plus, minus. Is the circuit perfect now? So remember, our goal is to find V output over V input. So let's start with, because the positive terminal is connected to the ground, the negative terminal has what we call what? Virtual ground. Because Vx is 0. Vx is 0. This Vx is 0. Everything here is 0 and 0. Get it? Okay. What is I1? I1 is V input minus 0 over R. Okay? Here they're saying R1, whatever. I'm just going to call it R. خلاص؟ كل الآرات عندنا في السيستم إيش؟ R. What is I2? Vn over R. Vn minus 0 over R. Vn minus 0 over R. So this is the first Vn. This is the first useful information. What is I input? Is I1 plus I2, which is equal to Vn over R. Okay. What is, so can I1 go inside this triangle? No. So I3 is what? Equal to I1. So this equals to I3. Another useful equation. So what is V output? I can have another expression of I3. You can do KVL. You can do KVL here. Or now we are smart enough to know that I3 is what? 0 minus V output. Both methods should work. So I'm going to do I3 is what? V 0 minus V output over R, which is minus V output over R. I can use this fact that V input over R equals minus V output over R. So V output equals to what? Minus V input. So what's the gain? The gain is minus 1. Trick. What is the input impedance? And we will finish the lecture here. The input impedance is V input over I input.
What is V input over I input? Is R over 2. It makes sense because what I see here is R to the ground, R to the ground, R and R parallel is what? R over 2. With that, I end this lecture. At home, please try to do this exercise. We will do this exercise next lecture. Then we will do a couple of checkpoints. And then hopefully, we are late a little bit, but not much. Because we have that quiz. Inshallah, we will catch up later. Do you have any question about today's lecture?